Well, hi everyone. Thanks so much for showing up for your math learning. Today we are reviewing how we solve equations. Both the linear ones that you worked on in grade 9 and the quadratic ones that we worked on in grade 10. We're going to get a bit of a review of some of these. I love these types of puzzles. These are great like bus stop puzzles. Things that you can do while you're waiting for the bus or combing your hair or in the shower and you need something to keep your mind busy. You can create equations and solve them. It's super fun. So, when we are looking at one of these things, we want to think about like our goal. Our goal is to solve, when we say solve the equation, it means solve for the unknown. So in this case, our unknown is x. I don't know what that is. It's some kind of number, but we don't know what it is yet. But unlike yesterday where we were just simplifying, here it's inside an equation. And the way you read this is you're saying 2 times the number I don't know yet, minus 5, is 13. And there's only one number in the universe of numbers that's going to make that true. And we have to find it. We're like the detectives. So the main skill that we're going to be using here are called inverse operations. People understand what we mean by inverse operations? What's the inverse of addition? Subtraction is the opposite of addition. Addition and subtraction are movement on the number line. If this is 0 and I add, I would go up. If this is 0 and I subtract, I go down. And addition and subtraction just move. Multiplication, what's the opposite? Good. So multiplication is like that many copies of that thing. Division is dividing something bigger into that size copies. So they're inverse of one another. They undo each other. Okay? What's the opposite of square? Multiply a number by itself. What's the inverse operation there? It is indeed square root. Yes. So if I tell you that the area of a square is 36, you take the square root of 36 and you solve for me the side length. Usually the formula goes in the other direction. I tell you the side length and you tell me the area. But we can go in both directions with inverse operations. We also use inverse operations to unfold these types of equations and make them speak their truth about their unknowns. So, in this case, I like to work on the subtraction first. What's the opposite of subtracting 5? Let's go ahead and add 5 to this side of the equation. If I do that, what must I also do to make sure the equal sign continues telling the truth? I must do that to both sides. Then I get a new equation that's 2x equals 13 plus 5 is 18. Notice that minus 5 plus 5 is 0. It's gone. It just disappears in a puff of chalk dust. Now, I have 2 times my mystery number gives me 18. Well, how do I undo that multiply by 2? I'm just going to divide by 2. If I do it to one side, what must I do to the other side? Good. So I do the same thing to both sides. Notice that 2 divided by 2 is 1. That's like saying 2 cookies and 2 people at the party. How many cookies does everyone get? So 1 multiplied by something, we don't usually write that down. I happen to be 45 times 1 years old. But when I tell it to you that way, is weird. It's a little bit like writing 1x. I don't write 1x, I just write x. Like if I'm introducing someone and I say, this is my 1x, that would be weird. I would just say, this is my x. That would still be weird. But anyway, x equals 18 divided by 2 is 9. And then I circle it, and I'm very proud. And I then go back and I check my answer. So this is how I check my answer. I rewrite the equation, 2x minus 5 equals 13. I check my hand. Hand, did you fall off? No, I didn't fall off when I rewrote the equation. Okay, good. So it's safe. It's safe, everyone. You're allowed to rewrite equations. You will not damage yourself. And then I substitute the x in with what I believe it to be, and I evaluate. 2 times 9, I do this with Bedmas, 18, and then I still subtract 5. Oh, 18 minus 5 is indeed 13. I get 13 equals 13. Hooray. And then I put a smiley face. And I'm very pleased with myself. And I maybe even pat myself on the back because it's good to feel good. Celebrate your wins in math and you'll start liking math more. Every little question that you can do, remember, a lot of people in this world can't do that question yet, but you just did. So feel superior to them. No. Feel good that you are demonstrating your math ability. Okay, so could I have divided by 2 first instead of doing the add 5 to both sides? I can if I like doing more work. I'm going to show you. I'm going to show you what it looks like. 2x minus 5 equals 13. We're going to do this problem so many times. Why? Because I want to show you the correct way, and this is to avoid a common error. A common error would be like, I'm going to try and get rid of that 2 this way. This is wrong. This is not correct. The reason is I'm dividing part of the equation on one side by 2 and the whole equation on the other side by 2, and that is not the same thing. When I divide, I have to divide the whole side of the equation by 2. That's okay. It will work. Now it's fine. Sometimes this is a useful shortcut, but here it's not. 2x divided by 2 is just x. Negative 5 divided by 2 is negative 5 divided by 2. No other simpler way to write it except for negative 2.5 if you like decimals and you're some kind of maniac. And 13 over 2 is 13 over 2. No simpler way to write it. Okay, and those of you who love fractions are going to love this. I just add 5 on 2 to both sides. And then I get x is equal to this, which is 18 on 2. Oh my goodness, we ended up in the same place. But I think you'll agree it was easier the first way. So do it the first way. I call that working in inverse Bedmas order. I first clean up any loose addition and subtraction, then clean up any multiplication and division, then do my square rooting, and then do anything higher order. But there's rarely higher order than that. Oftentimes you do your loose square rooting, and then you can break into a bracket or something like that. Okay, let's go. We're going to keep going. All right. So now here, oh my God, this one's harder. It's got n's on both sides. My variable is in 2 places. 3 times the mystery number minus 4 is the same thing as 6 times the mystery number plus 20. It's going to be harder to find the mystery number this time. But don't worry. Does anyone want to describe the general strategy? It's a general strategy here. Okay. My overall goal is to get n equals the number. That's what I want. And I'm going to do whatever I can to make that happen. So what I'm noticing is n's on both sides. That's super inconvenient. I have an extra positive 3n on that side. What could I do to both sides of the equation to simplify that up and have none of them? Divide by what? By 3? Okay, if I divide the whole side of the equation by 3, this is what we're going to get. 3n divided by 3 is n. Negative 4 divided by 3 is negative 4 divided by 3. 6n divided by 3 is 2n. And 20 divided by 3 is 20 divided by 3. Anyone loving this? So we're in that same problem, right? So I do want to move that 3n. I don't want to move the 3. The 3 is connected to the n by multiplication, so it's correct to use division to move it. But I want to move the whole thing, the 3n. I'm gonna say it a different way. 3n has been unnecessarily added to that side of the equation. How can I do the opposite of adding 3n to that side?
You could subtract 3n by both sides.
Yeah, let's remove 3 of the n's from both sides of the equation. So just like I can subtract a number, I can subtract some number of unknown numbers. So if I do that, now 3n minus n is 0. And now we're like, oh, that got a lot easier. This now looks like the other problem. So now I have 4 is equal to 6n minus 3n. Notice we're collecting like terms there. That's 3n and still plus 20. The 3n gets taken away from the 6n. That's why I write it that way, right underneath where I'm taking it away from. And then 20 is not a like term with n, so I can't collect it or interact it with there. So now I'm going to sit here until someone points out my error.
The negative.
What negative? Oh, right. Yeah, negative 4 is not the same thing as positive 4, so I better keep that negative there. Fantastic. So don't, be careful and check line by line. Am I still letting the equation tell its truth? It wants to tell its unique truth to us, and we need to just be mindful of that. So now I got 3n plus 20 equals negative 4. How can I get some numbers, either the 3 or the 20, away from that n? I want that n isolated and for it to tell us its truth. What are you thinking?
Minus 20 on both sides.
Love it. Let's take away 20 on both sides. Then we get negative 4 minus 20. That's like minus 24. That's like my bank account these days. So I had negative money in it, and then I'm still like, hey, bank, can I have some more? Yeah, and so I'm more in debt. All right. Now, negative 24 equals 3n. What do I do with that 3? Do I subtract it, add it, subtract it, multiply it, divide it? We're going to divide by 3 because we just remembered division is the opposite of multiplication. And then we get negative 24 divided by 3, and I don't know what that is, but my calculator just told me it's minus 8. And then I circle it, and I'm very pleased. I'm very, very pleased. And then you can try this on your own, substituting it back into the original equation, but ain't no one got time for that in this lesson. Okay, so this is the habit that you're going to have, is you then check it in your original. I can check it visually, right? 3n minus 4, that's negative 24, that's negative 28 on that side. On the other side, 6 times negative 8 is negative 48. Negative 48 plus 20 is indeed negative 28. Oh, it's negative 28 on both sides. So I get some mental arithmetic practice just checking my work there, and it's pleasurable. It is pleasurable to check and know that you are right. It feels good. So celebrate your wins. Let's keep going. Oh man, this one got harder. Oh no. We got numbers in front of those brackets. If only I was here yesterday, I would remember what to do. Yeah, you can go to guidance. What can we do here? Sam. Let's do the multiplication. Let's tidy up first. That's going to be a lot easier. So, multiply. I'm going to multiply this 2 in. I get 6x. I'm not going to make this silly error. Not again. No. Minus 8 is equal to 3. Do I multiply this 3? No. This is a set of instructions saying I have 3, and then I subtract 2 multiplied by the secret number plus 6. So I don't multiply that 3. It's going to be subtracted. But I do multiply this negative 2 in. Here. So I have 3 minus 2x minus 12. Negative 2 times 6 is negative 12. I bring that negative with me. It's far easier. Now we can simplify a little bit. I notice some like terms over here that I can work with, so let's continue tidying. 6x minus 8. We'll get back to you later. 3 minus 12. Okay, that's a 3-degree day that gets 12 degrees colder. It's now minus 9. Minus 9 minus 2x. Now, I'm in the same situation that we were in last problem. I've got x's on both sides. I've got numbers on both sides. And I want to know the value of x. So I'm going to move all my x's to one side of the equation. Which direction do you want to go? Do you want to bring them that way, or do you want to bring them that way? Strategy question. Both are correct. Why do you go left? I agree. Yes, I do the same thing. It's easier. I make errors too, but I notice that I make fewer errors with positive numbers than negative numbers. So try and make positive numbers when you've got a choice. And the more you're aware that you're making choices in these cases, the more you're really understanding the whole process and your role in it. So here, I'm going to move this by adding 2x to both sides. I notice that 2x has been unnecessarily subtracted from that side. We're going to move it over. We get 8x minus 8 equals minus 9. And now what do we do? Let's add 8. We're going to move that 8 to the other side. We move all of our x's to one side and all of the numbers to the other. And then we get 8x equals negative 1. So x is negative 8, right?
You have to divide it because you have 8x.
Oh, yeah, right. I just have to be stubborn with my rules. And when I'm multiplying, here 8 times x, I just do the opposite. divide. So then we get 8 divided by 8 is 8 cookies, 8 people. Sounds like a great party, 1 cookie for everyone. Just 1 x left, but I divide this side too. Negative 1/8 is our answer. That's the value of x. Very cool. And yes, they can be non-integers. All right. So now let's take a look at, oh, here's some more challenging ones. Oh my goodness. The things just changed up there. Now I got x's multiplied by x's. Okay. So what can we do with that? This one here. X minus 15 multiplied by 2x plus 7 is equal to 0. Or in other words, secret number minus 15 multiplied by 2 times secret number plus 7 is 0. What do you know about things that multiply to 0? If I have 2 things, let's say we live in this type of world, all right? Briefcases exist in this world. There is some number of briefcases, and inside those briefcases, there is the same amount of money in each one of those briefcases. And I tell you this piece of information. I have $0. Does that tell you how many briefcases I have? Or does it tell you how much money is in each briefcase? It could be a world where there's $0 in each briefcase. It doesn't matter how many briefcases I have $0. Or I just don't have any briefcases. Maybe there's lots of money in these briefcases, and Katie has 7 briefcases, each with 10 grand. She's got 70 grand, but I got 0 briefcases. 0 times 10,000 is still 0. But this is the point. I don't have some number of briefcases with some amount of money in each, because I told you I have $0. So if you're multiplying 2 things, one and they equal 0, one or both of them must be 0. And that's an important awareness that we need to have when we're solving quadratic equations. Equations that can have 2 solutions. So, in these situations, break them into 2 mini puzzles. X minus 15 equals 0, or 2x plus 7 equals 0. One of those 2 things must be true for that equation to equal 0. You follow my reasoning why? Yeah? Cool, good. We keep going. Thumbs up. You understand what I'm talking about. Briefcases and cash. I don't need to repeat the metaphor. People get it? Okay, cool, good. So now we just solve these 2. This one I just add 15 to both sides. Where x plus 15, so x equals 15. That's one solution. Over here, we're going to do it in this order. Subtract 7. 2x equals negative 7, and we divide. Cancels, cancels. X equals negative 7 on 2. Negative 7 halves, negative 3.5, same difference. Okay, so those are those. Now that was one where all the ingredients were already separated out into the 2 factors for you. What if I give you something like this that's not factored yet? How would you solve something that looks like that? Three multiplied by some mystery number squared minus 75 is 0. How would you do that? I also find posture helps when I'm struggling to stay paying attention to a lesson. I'll do some like moving around the room. People have some strategy of like how to overcome this one? No, eh? Is it ringing a bell for you? Yeah? Christian, right?
Yeah. Finding what will equal 75 because it's obviously some things that equal 75 just take 75 away and just 0.
Yeah, cool. So you can kind of puzzle it out, right? That is one strategy. It's a good one. Or, there's a couple ways we can do this one. So what Christian is suggesting is saying like, well, I know 3x squared should be 75. It's like saying add 75 to both sides. Then we get 3x squared equals 75. And now what can we do? What do you want to get rid of first? We can. I don't think you'll like it. It's again one of these things that we won't like. If I square root this side and square root that side, I get the square root of 3 multiplied by x equals the square root of 75. Anyone here know how to solve that? You can with some grade 11 skills. We'll get there, but not yet. And it would be gross. It's not my preference. If we were to work in inverse Bedmas order, what will we undo first? The multiplication or the square? Inverse Bedmas order. Let's get rid of the multiplication first. What's the opposite of multiply by 3? X squared equals 25. Now what?
We square root 25.
Yes, square root. Yeah, both sides. So we say square root. And so x is equal to 5. 5 squared is 25. So we're done, right?
No. How do you find the square root?
I have these things memorized. Having your squares memorized is really useful. So you're going to do these things on the calculator. You're going to say 25. You're going to push the square root button. It's going to tell you 5. Whenever that's an integer, whenever it doesn't have a whole mess of decimals after it, you want to be mildly surprised. And you want to look at your calculator and say, oh, the square root of 25 is 5. And then you verify it. And you're like, 5 times 5 is 25. And then your mind gets really active when you're using your calculator, and that's how you memorize these things. I'm not saying like have a cue card and be like 1, 4, 9, 16, 25, 36, 49. Too boring.
I have a question for D. Why is there 2 answers for X? Like,
For D? Because X is either 15, and it's making this 0, and then you've got 0 times some stuff. It would happen to be 37 there. Okay? So 0 times 37 is indeed 0. So we're good. That's one solution. But the other solution is, let's make that one 0. So then we have, oh, x is negative 7 halves. So 2 times negative 7 halves happens to be negative 7. Negative 7 plus 7 is 0. And then you've got some stuff times 0 is 0. So that's why quadratic equations can have 2 solutions. Just like this one should have 2 solutions, and no one is pointing out the error I'm making yet with this one. The degree of the equation tells you the number of possible solutions. And x squared can have 2. What's my other solution if it's not 5? Wilson, do you remember? Something squared is 25? Sydney? Negative 5 is good. So here we go. When we do the square root of some side, we have to do negative plus or minus the square root. This is your inverse operation. And let's think about why. So x is equal to plus or minus 5. That's the answer. Is that a notification sound or? Oh, that was in the hall. Okay, it wasn't one of you. I thought maybe I agitated someone's math trauma. Sorry if I trigger your math trauma. It's not my intent. So yeah, the plus or minus, like, no! Not the plus or minus again! Anyway, there you go. So we have plus or minus. And verify it. Negative 5 times negative 5. Oh yeah, negative times a negative is a positive. That's why that happens. Okay.
Wait, so before you go to the next question, how come it's plus and minus? Like, how do you know when to do that? Is it only when there's
Anytime you take the square root of both sides of an equation, we want plus or minus. The quadratic equation, you remember the quadratic equation? Negative b plus or minus the square root of b squared minus 4ac over 2a. Come on, it's a banger. It's an instant banger. You guys don't know this? Anyhow, we'll get there. But that one already has the plus or minus baked in to your solutions. And it shows you how your solutions are separated on the xy plane. We're getting there. Okay, this one here has not been arranged into beautiful little chunks for us yet. Does anyone know remember how to factor these? Here I'm looking for numbers that multiply to positive 16 and add to negative 10. So anyone know these? Multiplies to positive 16, adds to negative 10. Oh, I got something. They both must be negative because they're adding to a negative number but multiplying to a positive number. What two numbers multiply to 16 and add to 10?
-2 and -8.
These will do. So then we can rewrite this as x minus 2 times x minus 8. Don't worry, not a lot of problems like this in our work today, but I just wanted you to recall this, see this. We will spend a lot of time reviewing this. This is proper new stuff for us. Like we do this like it's new in this course. So then we have two little equations. X minus 2 might be 0. That might be the little factor that makes that 0. Or x minus 8 might be 0. In this case, x will be positive 2, and in this case, x will be positive 8. We get that by adding 8 to both sides, or adding 2 to both sides. And that's why the signs flip. You remember in grade 10 where when we got these things, we had to flip those signs to find out where the x-intercepts were. The reason they flip signs is you're finding the value of x that makes the whole little factor 0. So that's a little mini equation you solve. Okay, go for it. Try some of these. Get in there and practice these skills, everyone. Thank you so much for your engaged participation.